Hi everyone, thanks for joining us. Today we're going to have a look at the higher level 2022 paper question 6J. We have done most of the short questions at this stage and we'll eventually get to all of the paper, but J is what we're looking at today. It's a nice question about the Bohr model. But before I get into it, just the usual advice of the best thing to do here is to test yourself. And by test yourself, I mean, don't watch the rest of the video. Close everything, pretend you're in an exam hall, feel the nerves, open the blank page and see, can you answer this question? How does your answer compare to my sample answer? If you find that you're getting stuck early on or you're not sure about something, go back and check your book. Come back and play a little bit of the video that might just get you started. But the more that you can do on your own, that's telling you that number one, that you're learning, and number two, that you're getting ready for that exam. So that's the best thing to do. So hopefully you've now paused and gone off and done your own work, but let's get into the question. Okay, so I really like this question. I like the Bohr model in general. I am also a chemistry teacher, so it's just something that's in both of my subjects. So I really like it, but let's get into it. The question asks you to describe how the Bohr model of the atom explains emission line spectra. Now, I think for a short question for 7 marks, you could probably fill pages about this depending on what you knew. But the best approach I would suggest is a combination of a diagram and some bullet points. Okay, so it says describe. So describing to me, especially in physics, usually involves a diagram. But even the best of diagrams for this particular question needs a little bit of explanation too. So I've gone for some bullet points, and usually I write everything on the whiteboard, but today I've taken some of my writing from my sample answer just to save me from writing so much, because the pen that I use here isn't as good as this, just keep it nice and clear. But I'm going to do my diagram from scratch and just talk you through all the steps to make sure that it all makes sense, okay? And like I said, I think they're asking for a lot of information for a short question 7 marker when there's other ones in this set that were like definitions or a quick calculation. So if you're conscious of time, this might have been a tough one, but let's get into it anyway. So I'm going to start my diagram. I'll come back to my text, okay? It's asking us about atoms, the Bohr model of the atom, and it explains emission line spectra. So before I get into the emission line spectra bit, I'm just going to tell you about the Bohr model of the atom to begin with. And to do that, I'm going to draw an atom. I'm going to try anyway. And I'll need a pen. Here we go. I'll try and get mine over here. In the center of my atom, I have my nucleus. My pen is, for some reason, not cooperating. Let's try that again. Okay, let's just see if this works better. Weirdly, no. Okay, there we go. Now, the nucleus has protons and neutrons in it. So neutrons are neutral, protons are positive. So overall, it's got a positive force. That's not really super important for this. I'm just putting a positive to kind of show off that we've got a bunch of protons here together, okay? And outside of the nucleus, you've got electrons flying around like crazy, okay? We draw them in these very kind of sensible circles, but there's a little bit more than that going on. So draw a couple. Maybe I should use the circle tool and paint, but you wouldn't have that available to you in the exam, so I'm just going to do it as if I was doing my exam. I'm just going to draw 2. That should be there. And one name that's given to these lines, these are the paths that the electrons go on. And one of the names is energy level. Okay, so I'm going to call this energy level, just use E for short, energy level 1 and energy level 2. Now I have a sample answer with a neater diagram drawn as well, with capital E for energy level. And what that means is that there's this kind of a fixed level that an electron can kind of hang out in and do its thing. It usually orbits the nucleus within this kind of radius. And then if these are full, the electrons can go up to the next level and move around as they do, okay? So here's what I have in my answer for just so far in my description. In the Bohr model, electrons can only move between fixed energy levels. So these are the fixed energy levels. They don't really change. They're not moving up and down. They're just these lines. So I'm going to draw an electron down here in energy level 1. I'm not sure why that's coming up white. Okay, here's my electron. a little E minus, you might have seen before, show electron, E for electron, and minus because it's negative. It's hanging out in energy level 1. That's kind of a lower energy level. You could stay there all day long, happy out just to be there. But we give energy to that electron. So maybe we're putting a heat on it, or we're shining a light on it. If some other form of energy is being pushed in there, it can jump. Okay, so it's going to jump, make the jump from energy level 1 up to energy level 2. So here's my electron now. But that's not really a stable place for the electron, meaning you need to keep giving it all that energy for it to stay up there. It's not naturally happy to be there. That's kind of like it's had, like, if you can imagine, you've had loads and loads and loads of sugar and you're up in this higher level of energy, it won't last forever. It'll eventually decay back down or fall back down, okay? And this is how we're saying that in our description. So if these are bullet points, by the way, that's not actually very clear by me. I like bullet points because it just makes things a bit easier. So in the Bohr model, electrons can only move between fixed energy levels. If energy is given to an electron, it can jump from one energy level to the next. And I've said it's gone from energy level 1 to energy level 2. And just like I said, this is an excited state, in quotations. This is what we call it. It's excited. It's not stable. It can't stay there. It's not normally where it is. It's in a kind of a temporary excited state. Okay. That means it'll come back down. When the electron drops back down, back to energy level 1, it looks like I've loads of electrons, guys, but this is the same one moving, okay? Just in case you're getting confused with all my circles. This is the same guy moving about. When it drops back down, it releases energy. Whatever extra kind of energy it had to stay up there at energy level 2 gets released. And I'm going to make it look like a wave. Okay? So when the electron drops back down from energy level 2 back to 1, it released energy in the form of a photon of electromagnetic radiation. That's a packet of electromagnetic radiation. And often we might observe it as light. And here's the important bit, which is not on my diagram. That radiation, you can describe what's going on there. E equals hf. The energy and the frequency of that photon are related. So you've got energy is equal to Planck's constant times the frequency. Okay, so that's my little photon. That's what's describing the photon. And different atoms have different energy level jumps. What we mean by different atoms really is actually, probably should say, different elements. So if I do this in a chlorine, it's going to look different than a fluorine, and so on. A sodium is going to look different, and that's where the chemistry part kind of comes in, okay? They have different energy level jumps. So if I see a photon of light coming off of my sodium, it's going to have a different frequency of light, which actually kind of often means it's a different color than if I have them coming off of like a chlorine. So that tells me the frequency is related to the energy. So if I can observe the frequency, I can say it had a different energy level. That was a different amount of energy, because frequency and energy are so linked. And I know that there's a few of these jumps. I'm only talking here about one jump. But like elements will have several energy levels kind of like going on and on and on. And there'll be jumps happening all over. There'll be things going up and down from all different levels. So you'll have a whole series of these photons come out. And those photons are going to differ depending on the difference between the energy levels. And the spread of those energy levels depends on the element. So you're going to have kind of almost like a fingerprint of different frequencies coming off of your atom. Okay? I hope you're with me there, guys. There's quite a bit of chemistry and physics in there. So if anything there is not making sense, absolutely do flag it to me, okay? So just to say what I would write in my exam, different atoms have different energy level jumps. So as per E equals HF, the frequency of the light is unique to that element. That's the important part, okay? It's unique to that element. So I said fingerprint there when I was just talking to you, but it's unique. Every element is going to have a different bunch of frequencies come off of it. And those frequencies that we're observing, that's the emission line spectra. It's a profile of emitted frequencies. I'm calling it like a bunch or a whole heap of them coming together, but it's a profile. It's emitted frequencies. That's how we know the difference, okay? So that's probably, especially for 7 marks, I would say that's plenty, okay? The important things to have that you know that there's fixed energy levels. You know that when you excite an electron, it can jump up. That's an excited temporary state. It will fall back down to its first energy level. And in the process of falling that back down, a photon of electromagnetic radiation is emitted. You definitely should have your E equals HF in there. And to know that the difference in energy levels equals a different frequency, we are able to observe the frequencies of the light that comes off. And if we know the different frequencies, we can say, well, that's two different elements because they're letting off two different frequencies. Okay. And just on energy and frequency being related, this is the thing I like to do to show the waveforms kind of. So energy, high energy has high frequency. So if you have a high energy packet, I'm going to try to draw. This is not really part of your answer. It's just something to help fill in the gap between E and F. Oh, that's not a great one, but you get the idea. It's really dense, right? That's high energy. And if you're just like a person standing here, you're getting hit with a wavefront, like you're getting hit by these bits really, really often. It's really, really high frequency. And high frequency electromagnetic radiation tends to do a lot of damage. But if it's a nice, relaxed, low wave like that, it's not going to do as much damage. It has a low frequency and low energy. Okay, just something to remind you about that if that was something probably done way back in your waves chapter, a bit separate to the Bohr model stuff, but just might help to understand how energy and frequency are connected. Okay. So again, you can have a look if you got this far, or if you got some variation of this, you had the key elements in it. Great work. If it's something that you were not so sure how to answer, that's definitely a sign that you need to revise it and go back into your textbook and stuff like that. Go back over your notes, whatever way you like to revise. If there's anything I said that you kind of didn't get, you didn't like the sound of that didn't really make sense to you, absolutely let me know. If there are, and as usual, if there are other questions that, sorry, I meant to say, you can also look at the marking scheme for this and my sample answer on the website, so you can kind of compare. And if there's anything that you're saying, oh, you said it this way and I said it that way, would my way be okay? Send that on. Absolutely, would love to hear from you. And in a more general way, if you have other questions about this exam paper, this exam question, a different exam paper, a textbook question, anything at all really that's related to Leaving Cert Physics, please send on an email. There's a contact page on the website, and my email is info@physicshelp.ie. I have also Instagram, but I must say I don't use it very much. So the best thing is probably send an email or use the website. Okay. I hope it helped, and I hope that it made sense to you, and that your revision is going well. So thanks very much for watching. I'll leave you at that for today. Thank you.